input impedance. Input impedance of a transmission line input impedance of a transmission line terminated with any load impedance. Terminated with any load impedance. So ZR. This is a very important topic, input impedance. Input impedance of a transmission line terminated with any load impedance ZR. That is a basic transmission line like this, having some load impedance ZR. This is input side having some length L. So this is called input impedance. Looking into the transmission line, Zin, some voltage, source voltage Vs, some input current Is, some load current IR, some load voltage VR. This is a basic transmission line structure. Now I am going for Zin value. So this Zin value is given by Zin is equal to, and one important thing is Z0. This is a characteristic impedance of the line. So characteristic impedance, this is one of the property of the line. So generally for any transmission line they will mention what is the characteristic impedance. So Zin is equal to Z0 into ZR plus Z0 tan H gamma L by Z0 plus ZR tan H gamma L. One thing here is, I am not going for the proof of the formula because it will a lengthy procedure to go for the proof. You can refer any textbooks what we suggested for reference purpose. There is two purpose, but the thing is you have to keep in mind this formula, very important formula. That is, to solve the problems you need to remember this. That's why directly I am going for the formulas, not for the proofs at all. So this is for any general transmission line having some length L. The input impedance is given by Zin is equal to Z0 into ZR plus Z0 tan H hyperbolic gamma L by Z0 plus ZR tan H gamma L. Here Z0 is characteristic impedance, ZR is load impedance, gamma is propagation constant, L is length of the line. Now I am considering for different cases. Suppose open circuit line. That means at load end that is opened. So opened means what is the impedance value? Infinite value. So if the circuit is opened at load end means value, that is, there is no current at all. Current zero means impedance is infinite. So ZR is equal to infinite. This is the ideal case. Now what happens to Zin? So then Zin is equal to ZOC. Because this is a particular case, that's why I am representing with the open circuit. So input impedance is nothing but open circuit impedance. ZOC is equal to Z0 into I am taking ZR common here. Because if you take ZR common in the numerator, what happens? It is 1 plus Z0 by ZR tan H gamma L by take ZR common here. In the denominator also take ZR common. Then what happens? This is Z0 by ZR plus tan hyperbolic gamma L. Put ZR is equal to infinite because this ZR cancels out. If put ZR is equal to infinity here, ZR is equal to infinity here, this term becomes 0, this term becomes 0. So the only remaining thing is Z0 into 1 plus 0. So Z0 into 1 by Z0 by ZR. This is also 0. So the only remaining thing is tan H gamma L. So tan hyperbolic gamma L. Sorry. This is Z0 into 1 by tan H gamma L. So that is equal to Z0 into 1 by tan H gamma L. I can write it cot hyperbolic gamma L. Therefore, ZOC, that is open circuit case, that is characteristic impedance is, open circuit impedance is characteristic impedance multiplied with Z0 into cot H hyperbolic gamma L. Actually, there is no need to remember this formula. If you remember this thing, input impedance of a general transmission line, easily you can derive this. ZOC is equal to Z0 into cot hyperbolic gamma L. Next one is short circuit line case. Short circuit line. That is at the load end, that is short circuited. That is this kind of line. So then what is ZR value? If it is short circuited, means ZR is equal to 0. So ZR is equal to 0 for a short circuited line. So put ZR is equal to 0 in the standard input impedance. So therefore Zin is equal to, we know that Zin is equal to Z0 into ZR plus Z0 tan hyperbolic gamma L by Z0 plus ZR tan hyperbolic gamma L. This is the general formula. Put ZR is equal to 0 in this one. Therefore, what is the remaining thing? Zn is equal to Z0 into, if you put ZR is equal to 0, the remaining thing is Z0 tan H gamma L, Z0 tan H gamma L by Z0 plus ZR 0. So the Z0 cancels out. Therefore, Zn is equal to, I can represent this short circuit also, SC, short circuit, is equal to Z0 tan hyperbolic gamma L. Tan hyperbolic gamma L. Here, now, do one thing. ZOC, that is open circuit impedance, multiplied with short circuit impedance. Then what happens? So ZOC is nothing but Z0 cot hyperbolic gamma L. ZSC is Z0 into tan hyperbolic gamma L. So cot H gamma L, tan H gamma L cancels out because cot H gamma L is nothing but 1 by tan H gamma L. So those two cancels out. So the remaining thing is Z0 square. Therefore, Z0 is equal to square root of ZSC into ZOC. That is, the characteristic impedance of a transmission line is nothing but square root of open circuit impedance multiplied with short circuit impedance. Very, very important formula. You have to keep in mind this thing. So, if any one thing is given, that is suppose open circuit impedance is given, characteristic impedance is given, then you can easily calculate short circuit impedance by using this formula. This is a short. This is one of the important formula we derived from this too. So this is nothing but geometric mean of short circuit impedance and open circuit impedance. Gives characteristic impedance of a transmission line. Next one is matched line. Matched line. That is, a line is said to be matched. A line is said to be matched when it is terminated by its characteristic impedance only. By its characteristic impedance only. By its characteristic impedance only. That is the case of matched line. So generally this matching line is used for maximum power transfer. That is, if you terminate a load with its characteristic impedance itself, then maximum power transfer takes place. That is generally we will do in networks. So for a matched line, ZR is equal to Z0, that is the load impedance equal to characteristic impedance. Then what happens to the input impedance? Zin. Just substitute ZR is equal to Z0. Therefore Z0 into ZR plus. So ZR is nothing but Z0 plus Z0 tan hyperbolic gamma L by Z0 plus ZR tan H gamma L. Original formula. ZR is nothing but Z0. Z0 tan hyperbolic gamma L. So what happens? Numerator and denominator cancels. What is the remaining thing? Z0 only. That is, the input impedance is Z0 only. It's very important statement. That is, if a line is terminated with its characteristic impedance, the input seen at the transmission line, input side is, that is Zin is the characteristic impedance only. The characteristic impedance only. Of course, this is a condition for maximum power transfer also. That is, to get maximum power transfer, we have to terminate the load by its own characteristic impedance. We will now discuss for a lossless line, what is the input impedance. So we know that for a general transmission line, Zin is equal to Z0 into ZR plus Z0 tan hyperbolic gamma L by Z0 plus ZR tan hyperbolic gamma L. This is the input impedance for a general transmission line, where gamma is equal to alpha plus j beta. Now for a lossless transmission line. For a lossless transmission line, what is the thing? Alpha is equal to 0. Attenuation constant is equal to 0. Only beta exists. Only beta presents. Of course, that is beta value is omega into square root of LC. Now what happens to the input impedance? Therefore, Zin is equal to, that is input impedance is equal to Z0 into ZR plus Z0 tan hyperbolic gamma is nothing but alpha plus j beta. So alpha is 0. So only j beta exists. J beta L by Z0 plus ZR tan hyperbolic j beta L. Now, by using a mathematical identity, tan hyperbolic j beta L is equal to j tan beta L. So So we can write like this: tan hyperbolic j beta l is j tan beta l, which is a trigonometric identity. This is because of, since cos hyperbolic j beta l is equal to cos beta l only, sin hyperbolic j beta l is equal to j sin beta l. Now tan hj beta l is nothing but sin hyperbolic j beta l by cos hyperbolic j beta l, that is nothing but j sin beta l by cos beta l, nothing but j tan beta l. So this is a trigonometric identity. So with this identity, what is the thing? Therefore Z input impedance is equal to Z0 into ZR plus j Z0 tan beta l by Z0 plus j ZR tan beta l. So this is the input impedance of a lossless transmission line. Input impedance of a lossless transmission line. Very, very important thing. Now for a lossless transmission line, what is ZOC? So ZOC means open circuit impedance. Open circuit impedance means ZR is equal to infinite. So put ZR is equal to infinity in numerator and denominator. Otherwise, what the procedure we did for the previous one, use the same procedure. If you go for like that, you will get ZOC is equal to minus j Z0 cot beta l. Short circuit impedance ZSC is equal to j Z0 tan beta l. Suppose if you multiply these two things, ZOC into ZSC, you will get only Z0 square only. Therefore Z0 is equal to square root of ZOC ZSC. So this formula holds for any type of line, whether it is a lossless line, a distortionless line, general transmission line. The characteristic impedance is nothing but square root of open circuit impedance multiplied with short circuit impedance. If you observe, the open circuit impedance and the short circuit impedance of a lossless transmission lines are having only imaginary parts. That is something like these reactive parts, where suppose for a inductance, suppose what is the inductive reactance? J omega L part. J omega L is the impedance of a inductor. Omega L is the reactive part. Similarly, minus J by omega C is the impedance of a capacitor. What is the reactive part? 1 by omega C, or minus 1 by omega C is the reactive part. So if you observe this open circuit impedance and short circuit impedance also, these are looking like a reactances. Okay, we will discuss more clear about this in our later discussion.